Okay, good evening students. So in this video, we will see how to convert a delta connected resistors into an equivalent star connected resistance. I think in the last class we discussed the definition for delta connection and we discussed the definition for star connection also. And if you observe the delta and star connection, in delta connection we are having three resistors, and in star connection also we are having three resistors, and in delta also we are having three outcoming terminals, and in star also we are having three outcoming terminals. Right. Now first we should know exactly what is the meaning of delta to star conversion. So the meaning of delta to star conversion means we have to represent a delta equivalent. We have to represent a delta equivalent star connection. So that is the meaning of delta to star connection. That means indirectly, so we need to find out a star connection that is equivalent to the delta. That means the star values. So we need to find out the star values from the given delta. And keep in mind, so if we are converting from delta to star means the performance of the delta connected resistance and the equivalent star connected resistance must be same. There should not be any change in the performance. Keep this in mind. So with that condition, now I will try to convert a delta into a star equivalent circuit or connection by considering the resistors. So now I will write the clear meaning of this. So the meaning of delta to star conversion means we have to represent delta equivalent star values. So there is a meaning of delta to star conversion, right? So to convert the given delta into equivalent star, first what I'm doing means first I will draw a delta connected resistors. So as we know very well that in case of delta, so we are having three resistors and all the three resistors are connected in such a manner to form a closed loop. Keep in mind. And these are my terminals. So in case of delta, we are getting three outcoming terminals. Now we are going to convert this delta into equivalent star. And I will mention the resistors. I will consider three resistors here. Here I will keep one resistor, and here I will keep another resistor, and then one more resistor here. Right. And I will use red color for my delta connection. This is my first resistor. I consider the resistance values R1, and this is the second resistor. I consider the resistance values R2, and so this is my third resistor in the delta connection. I consider the resistance as R3. Right. So that means this is the given delta connection. So we need to represent equivalent star for this delta. So we'll see how to convert or how to find out equivalent star for this delta. Right. So as usual, the outcoming terminals I will consider some other color. Right. So here I consider the outcoming terminal as A, and this terminal as B, and this terminal as C. Right. So now we are going to convert this delta connection into star. So that means indirectly, so we need to find an equivalent star for this delta connection. Yes or no, that is what we are doing. And we need to find out the values of this star connection. So that is the meaning of delta to star connection. In star also we are having three resistors with three terminals. The only difference here is in case of a star we are having a star point, but in case of delta we are having closed path. There is the only difference here. And the coming to star connection, I consider the star connected resistors as that is RA, right? Consider that as RB, consider that as RC. So we need to find out what is the value of this RA and what is the value of RB and what is the value of RC. Right, that is the meaning of delta to star connection. Now what I'm doing means I will draw that converted star as a separate diagram. Here I will write this is the converted star connection for the given delta connected resistors. So in case of star also I told you that we're having only three resistors and we're having three outcoming terminals. So we need to find out what is the value of this star resistors. So we need to find out the values of this star connection. So I am considering this resistance as RA and I am considering this resistance as RB and I am considering this resistance as RC. I will indicate clearly. So this resistance is RA, right, and this resistance is RB and this resistance is RC. So in this star also we are having how many outcoming terminals? So we are having three outcoming terminals. So this terminal is A and this terminal is B and one more terminal is C. So right. So we need to find out what is the value of that RA and what is the value of RB and what is the value of RC. Keep in mind we are not changing anything, just we are replacing that connection. Here also we are having three resistors. So we are replacing the connection from delta to star and we need to find out the values, okay now, and without affecting the performance, right? That means we need to find out equivalent values. So that is the meaning of delta to star. A, B and C. I hope all of you understood, right, the meaning of delta to star connection. So now what I'm doing means, okay now, if you observe this delta connection here, forget about star connection. So if you observe this delta connection, so here we are having three outcoming terminals. Now what I'm doing means, first I will find out the equivalent resistances between any 2 points. So you can observe here, if you want to find out the equivalent resistance between A and B, okay now, if you want to find out the equivalent resistance between A and B, how to find out I will show you. So equivalent, so resistance, so between A and B. And I consider that equivalent resistance as or AB, okay, or suffix capital A. So we can follow the general procedure. So how we are calculating the equivalent resistance, in the same way we'll do it. Right. So we need to find out the equivalent resistance between only 2 points, that is A and B. If you want to find out the equivalent resistance between 2 points, that is A and B, you can observe here. So what are the terminal C? The terminal C, we are not connecting anything here. Yes or no? We are finding the equivalent distance between the 2 points, that is A and B. That means you can observe here. So if you draw the connection diagram between A and B and with terminal C, it looks like this. Observe here. I'm just drawing rough diagram to understand exactly how we are going to find out the equivalent distance between A and B. So this resistance is R1. Yes or no? So this resistance is R1, and we are having the remaining two resistors, right? From A to point C and from B to point C. It's very, very important explanation. Now this point is C, but we are finding the equivalent resistance between A and B only. So if we are finding the equivalent resistance between A and B, now this terminal C, it is open circuit, right? We are not finding, we are not considering this terminal. That means, so simply, if you observe this one, okay, now, so if you observe this one, simply it looks like, so if you consider one current here now from this point, so this current I, it is divided into only two currents only here. If you consider this current I1, okay, now, and if you consider this current as I2, so this I1 current is passing through R3, and so there is no connection for C, right? We are considering from between A and B only. So this I1 current is again passing through R2. That means, so now in this case, this resistor R3 and R2, they are in series. And again R3 and R2 in series with parallel to R1. So that is the meaning of, or that is the value of the equivalent resistance between A and B. So once again I'm repeating here. If you want to find out the equivalent distance between the points C and B, so the C point we are not connecting, simply it will act like open. So if you want to find out the equivalent distance between A and B, so simply if you observe this R3 and R2, they are in series because we are not connecting anything here to the C. So R3 and R2, they are in series, and this combination, it is in parallel to R1, right? So that means simply RAB, the equivalent distance between RAB means simply, so R1 in parallel to R2 plus R3. Okay, now, so R1 in parallel to R2 plus R3. It's like a two resistors in parallel connection. So one resistance is, so R1, and the another resistance is what? R2 plus R3. So I can write like this. Observe here, R1 in parallel, right? So that means into, so in parallel with which resistors? So easily we can identify, that is R2 plus R3. So once if you understood this thing now, the remaining things are very simple. They are parallel, right? So if two resistors are in parallel, what is equivalent resistance? R1 R2 by R1 plus R2, right? Here also the same thing here. So R1 is in parallel to R2 plus R3. So the equivalent distance becomes R1 into R2 plus R3 divided by R1 plus R2 now. That is R1 plus the second resistance is here is how much? That is R2 plus R3. They are in series, right? Both. So this is how we can find out the equivalent resistance across or between the points A and B. Okay, now understood, right? I will consider this equation as equation number 1. Right. So once if you understood the equivalent distance between the points A and B, so now we are doing for delta connection, keep in mind. I will write here also, no problem. So this is the delta connection, right? So now I am analyzing the delta connection only. And this is the star connection. Now what we are doing means we are finding the equivalent resistance. Similarly, I can write the equivalent resistance between the points B and C. Can we try now? So B and C. So when it comes to B and C now so corresponding to B and C, so which resistor is in parallel to which resistance? We can easily identify, right? When it comes to RBC, we are finding the equivalent resistance between B and C. Now this R1 and R3, these two, they are in series, and again they are parallel to R2 now. That means I can write like this: R2, it is in parallel to series combination of R3 plus R1. So divided by, so R2 plus R3 plus R1, right? So instead of writing like that, I can write R1 plus R2 plus R3. Is there any difficult? I think, right? So R3. I consider this equation as number 2. Similarly, so we need to find out the equivalent resistance between the points, and then the remaining points are what? C and A, right? That is or suffix Ca. We are finding the equivalent distance between the points C and A. So now in this case, if you observe the connection, now which resistor is in parallel to which resistors? R3 between C and A. R3, it is in parallel to R1 plus R2. Yes or no? That is, I can write R3 into R1 plus R2 divided by, so again I am writing the same way, that is R1 plus R2 plus R3. So R1 plus R2 plus R3, and consider this equation as number 3. Is there any difficult? So just we find out the equivalent resistances between the 2 points of delta connection, that is between A and B, and between B and C, and between C and D. Now what I am doing means, again similarly I will find out the equivalent resistance between the 2 points for a star connection. Can we? But when it comes to star now, it is very easy to find out the equivalent resistance. I will write clearly: equivalent resistance between A. Here also A and B only, right? So between A and B. So here also between A and B. Now I am writing the equivalent resistance. It is for star connection, that is RAB. Yes, can anyone tell me the equivalent resistance? So RAB equals to, now we can analyze like this. Observe here. So we need to find out only the equivalent resistance between R, A and B. That means if you consider some current here now from this point, so the current will passing through here up to this point. Now is there any connection to C? There is no connection, right? This C connection is open. Simply the current will passes through RB. So the current passing through RA and RB is same. Now they are in series simply. So the equivalent distance between A and B simply, that is equals to RA plus RB. Similarly here also, I will consider this equation number as 4. And similarly we will write the equivalent resistance between B and C or BC. So very simple, right, when it comes to star. So again RBC, that is equals to, so RB and C, that is equals to RB plus RC. And again consider, so this equation is 5. Just we are finding the equivalent resistance between the 2 points for delta and for star. This is an equivalent star, right? So this is a equivalent star. We will see what it means exactly. Similarly, R, capital R. So BC completed now CA. So RCA. So that is equals to RC plus RA, right? RC plus RA. And consider this equation number as 6. Right. So this equation number is 6. Now, so once if you find out the equivalent resistance for delta and the equivalent resistance for star. So what I'm telling means we are finding or we are drawing an equivalent star connection for this delta. So what it means I already told you that if we are converting a delta connected resistors into star, so what we are doing is indirectly the performance shown by the delta connection and the performance shown by the equivalent star connection must be same. There is no change in the performance. So that means indirectly the equivalent distance between the 2 points A and B for this delta connection and the equivalent distance between the 2 points A and B for this star connection must be same because it is an equivalent star, right? So the equivalent star to this delta. So that means the equivalent resistance between A and B for this star and the equivalent resistance between A and B for this delta must be same. So that is the meaning of equivalent connection. So right. So now what I'm doing means I can equate the equivalent resistances between A and B for both delta and star connection, right? Now, so equate, so which equation and which equation? So now you need to equate 1 and 4, right? That is RAB here and here also RAB. So equate 1 and 4. That is I can write. So R1 into R2 plus R3. So divided by R1 plus R2 plus R3. So simply we are equating both star and delta equivalent resistances. They must be equal, right? That is the meaning of conversion. R2 plus R3. So this must be equals to, so the equivalent distance between A and B in case of star, that is RA plus RB. And again consider this equation number as 7. So this equation number is 7. And similarly equate 2 and 5. So if we equate 2 and 5 we'll get R2. So into R3 plus R1, right? So divided by, again same. So R1 plus R2 plus R2 plus R3. That must be equals to RBC in star connection. That is RB plus RC. and consider this equation as 8. Consider this equation as number 8. Similarly, so equate 3 and 6, that is equals to R3 into R1 plus R2, so divided by, so again same, right? So R1 plus R2 plus R3, that is R1 plus R2 plus R3, that is equals to RCA in case of star connection, that is equals to RC plus RA. So consider this equation number as 9. So once if you understood up to these equations, now what I'm doing means, okay now, so indirectly what we are doing here means, we need to find the expression for this star values now, that is RA, RB and RC in terms of delta values. But if you equate these two now, we are not getting only RA, we are getting RA plus RB, RB plus RC, RC plus RA. But I want the values for what? Only RA in terms of R1, R2 and R3. And similarly RB in terms of R1, so R2 and R3. So for that purpose what I am doing means, you can observe here, I am subtracting this equation number 7 and equation number 9. If you subtract this equation number 7 and equation number 9, here also RA there, here also RA there now. So RA gets cancelled, then you will get RB minus RC will get. Yes or no? So you will get RB minus RC. So like that we are doing. And similarly observe, if you subtract 8 and 9, so if you subtract 8 and 9, what you will get? RC gets cancelled now. You will get RB minus RA. So you will get RB minus RA. And we are having already RA plus RB now. Then if you add the resultant equation, and that is you will get RB, that is RB minus RA you will get, and this value, then you will get one resistance value. That is what we are going to do now. So what I am doing now, so I am subtracting this equation number 7 and equation number 8. If you subtract 7 and 8, so we are getting RA minus RC now. Directly I am writing. If you subtract equation number 7 minus equation number 8. Yes or no? That is what I am doing here. So we are going to subtract, so equation number 7 and equation number 8. So you can observe here once again. So if you subtract 7 and 8, this is RA plus RB, this is RB plus RC. So this RB gets cancelled. Then you will get RA minus RC, right? Then you will get RA minus RC, that is equals to. So we need to separate these two now. That is R1 into R2 plus R3. So R1 into R2 plus R3. So minus the LCM same, minus L R2 into R3 plus R1. So divided by, so only the same LCM, right? That is R1 plus R2 plus R3. So it is very, very important. Simply I am subtracting equation 7 and equation 9. Then you will get the expression as RA minus RC. That is equals to R1 R2 plus R3 minus R2 into R3 plus R1 divided by R1 plus R2 plus R3. So consider that equation as number 10. I am considering this equation as number 10, right? So if you got this expression RA minus RC, and if you observe the previous expression now, we are having RC plus RA now, the ninth expression. The ninth expression is RC plus RA, and the 10th one is RA minus RC. So what I'm doing means, so now I'm adding add, so equation, which number? So 9 and 10. So that's what we are doing here. If you add the equations, so 9 and 10. So the ninth equation is RC plus RA. But the 10th equation is what? RA plus, it's not plus, RA minus RC. So RC gets cancelled. Then you will get 2 RA. It's very, very important. You will get finally 2 RA. So 2 RA, that is equals to, so first I will write the ninth expression. So what is the ninth expression we are having? R3 into R1 plus R2 now. Right. So that is R3 into, so R1 plus R2. We are adding 10, right? So what is the 10th equation? Plus R1 into R2 plus R3 minus R2 into R3 plus R1. Just we are adding equation number 9 and equation number 10. So what about denominator? The denominator is same. That is R1 plus R2 plus R3. Now simplify this one. This is equals to, I will write simplification because it is very, very important for me. I am expanding, that is R3, R1, right? Plus R3, R2 plus R1, R2 plus R1, R3 minus R2, R3 minus R1, R2. Understood, everyone? Then divided by, so we got R1 plus R2 plus R3. Now, if you observe this equation, and we need to observe which terms will get cancelled. So R2, R3 gets cancelled, R2, R3 gets cancelled, right? R1, R2 gets cancelled, R1, R2 gets cancelled. Finally, you will get the expression as, so we are having only two terms, that is R1, R3, R1, R3. So then you will get 2 times of R1, R3 divided by R1 plus R2 plus R3. So finally, so we are getting the expression for RA. So where RA is what? The star connected resistor, right? And that star connected resistor in terms of delta connected resistors, that is, so R1, R2 and R3. So this 2 and that 2 also will get cancelled. Finally, the expression for the star connected resistor, that is RA, this is what we want finally. So RA equals to, so what is the expression we got? R1, R3. So very, very important. Divided by R1 plus R2 plus R3. So this is how we need to find out delta equivalent star values. So where RA is the star value, but it is expressed in terms of delta values. That is the meaning of delta to star conversion. We need to express the star values in terms of delta. All of you understood how we find out the value of star in terms of delta. This is RA. So once if you analyze this star, so star resistor RA, I can write directly. I don't want to do all those things. I don't want to do all this business. Directly I can write RB value and RC value also. You can observe here. So how the RA value we can guess from the connection. So where RA means this is the RA, right? Yes or no? I will indicate there also. So this resistor is RA actually. This resistance is RA. I will reduce the font so that it can fit there, right? So actually this resistance is RA. Now if you observe this RA expression, so RA, how the expression we got? R1, R3 na? If you observe here. So R1, R3 for this RA. So this R1, R3 they are opposite now, their side. So in the middle I consider RA. This is R1, R3 by R1 plus R2 plus R3. So with this analysis, I will write the expression for this is RB, right? I will write that expression for RB directly. So without having any problem. So RB equals to, I don't want to do all these things again. I don't want to add, subtract. Similarly, I can write simply. Similarly, RB equals to, what is the resistors opposite to RB? R1, R2 now, right? I can write like this. R2, R1. Again same, denominator. The denominator is same, that is always R1 plus R2 plus R3 only. So finally, these are the expressions for the delta equivalent star values. That is RA, RB and RC. So we find out the star connected resistance values in terms of delta connected resistors. Can you guess RC? You can observe here. This is RC, right? This RC is connected between R2 and R3 now. So between R2 and R3 means I can write R2 into R3 divided by, again say R1 plus R2 plus R3. Okay, so in this video, I will complete the derivation only from delta to star. Okay, now that star to delta, that will take very less time. So by using this delta to star converted expressions, okay, now I will do that star to delta conversion in the class, right? So please all of you go through this video completely and try to understood. And if you are having any doubt now, you can respond in the classroom and copy it everything into your notebook. And remember how I am writing the star equivalent or star values. That is delta equivalent star values. Once again I am telling, if you want to write the expression for RA, RA equals to R1, R3 by R1 plus R2 plus R3. And RB equals to R1, R2 by R1 plus R2 plus R3. And similarly RC equals to R2, R3 by R1 plus R2 plus R3. So this is how we can find out delta equivalent star values. Okay, now so with this I am closing.